So good evening, welcome to Sakala Vidya Educational Channel. So welcome to our differential equation chapter for Engineering Mathematics 2, and also it will be useful for PGT and TGT, SCS school assistant examination, different examinations also. So we have been discussing problems on formation of differential equations. So far we have covered actually here 14 problems. So now let us solve 15th problem onwards. Okay, let us write 15th problem. So 15th question. Find the differential equation. Find the differential equation. Find the differential equation of family of circles, having the center on x-axis, and passing through the origin, and passing through the origin. So let me read the question once again. Find the differential equation of family of circles having the center on x-axis and passing through the origin. So first of all, we know that the general equation of the circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. So now actually the center is minus g comma minus f. According to the problem, center lies on x-axis. Since center lies on x-axis, its y coordinate must be 0. So f is equal to 0, and also passes through the origin means the c becomes 0. So now substituting f for 0 and c for 0, we get the equation of the family of circles having the center on x-axis and passing through the origin. So now we will be getting here actually one arbitrary constant. By differentiating with respect to both sides, we get the required differential equation. So let us proceed for the method now. So first write down here the general equation of the circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. So now what is the center of this circle? Center equals to so minus half times x coefficient, that is minus g comma minus half times y coefficient minus f. Okay, but according to the problem actually here center lies on x-axis. Okay, as center lies on x-axis, that is y coordinate means minus f is equal to 0 means f is equal to 0. and also passing through the origin and passes through origin and passes through origin. So, and passes through origin means that is C becomes 0. So, that means in the place of x 0, 0, 0, 0, C must be 0. So, that is why now we are going to get the equation of the family of circles having center on x axis and passing through the origin. So, that we are going to write now. So, that means we can write the equation of the family of circles whose center on x-axis and passing through the origin. Is x square plus y square plus 2gx, because f is 0, the y term will be absent, 2gx, c is also 0. So, 2gx is equal to 0. So, equation 1 where g is a parameter. So, that means it contains only one parameter. So, that is why we need to eliminate this g. How to eliminate g? Just by differentiating, that is all. So, differentiating both sides, with respect to x. Then what do we get? See, x square differentiation is 2x plus y square differentiation is 2y plus 2g is a parameter and x differentiation is 1 equal to 0. So, here my dear students, remember, so we did mistake here. Once again repeat here, derivative of x square is 2x, derivative of y square is 2y, again y derivative is y1 plus 2g to x differentiation 1 equals to 0. So, now divide throughout by 2, divide both sides by 2, then what do we get? Yes, we get x plus y y1 plus g equals to 0. Now, g equals to, here we can have minus x and minus y y1. Substitute g is equal to minus x minus y y1 in equation 1. So, that means substituting g is equal to minus x minus y y1 in equation 1. That means in the place of g, let us replace minus x minus y y1. So, that means we get x square plus y square 2 of minus x minus y y1 of x equal to 0. Let us make it simplify now. Open the bracket. So, x square plus y square, so minus 2x into x minus 2x square and minus 2x into y y1 minus 2x y y1 equals to 0. Then x square minus 2x square we can have minus x square. So, y square minus x square minus 2xy, this y1 we can write dy by dx equal to 0. So this is the required differential equation. This is the required differential equation. So therefore, this is the required differential equation. So if you have any doubt, you can chat with me. I hope you might have understood well. Okay. Right. Let me repeat once again here. See, check. Here question is, find the differential equation of family of circles having the center on x-axis and passing through the origin. The general equation of the circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. So according to the problem, center, actually here center is equal to minus g comma minus f. According to the problems, as center lies on x-axis, y coordinate must be equal to 0. So minus f is equal to 0 means f is equal to 0. And passes through the origin means c become constant of the constant term become 0. So put f is equal to 0, c is equal to 0 here. Then this becomes 0 and this becomes 0. We have x square plus y square plus 2gx is equal to 0, which represents the equation of family of circles center on lies on x-axis and passing through the origin is given by x square plus y square plus 2gx is equal to 0, where g is a parameter. So differentiating both sides with respect to x. Derivative of x square with respect to x is 2x. Derivative of y square with respect to x is 2y. Y derivative is y1 plus 2g into derivative of x is 1 equal to 0. Now actually we have in each term 2 is the common. Divide both sides by 2. So then we get x plus y y1 plus g is equal to 0. From this we can find out the value of g in terms of x comma y and y1. So transposing this side, negative x or negative y y1 or minus x minus y y1. Substitute this value in equation 1. Substituting g is equal to minus x minus y y1 in equation 1. So we get x square plus y square plus 2 times of, in the place of g, minus x minus y y1 into x. So let us open the brackets. X square plus y square plus 2x into minus x minus 2x square plus 2x into minus y y1 minus 2x y y1 is equal to 0. So now simplifying these two terms, y square, x square minus 2x square is minus x square minus 2xy, y1 means dy by dx. So this is the required differential equation. Okay, let us proceed to next question now. 16th question. 16th question. 16th question. Form the differential equation. Form the differential equation. Form the differential equation. Form the differential equation of the family of circles, of the family of circles, family of circles, family of circles, x minus a whole square plus y minus b whole square is equal to r square, where a comma b, a and b are parameters and r is constant, r is constant, r is constant. So then here we are asked to form the differential equation of the family of the circles x minus a whole square plus y minus b whole square is equal to r square, where a and b are parameters. Two parameters are there, where r is the constant. R is fixed, but these are the constant, they may vary, that's why they said to be the arbitrary constants. So this form is known as central form of a circle. So that means x minus a whole square plus y minus b whole square is equal to r square represents equation of the circle whose center is at a comma b having radius r. So that's why this is called central form of the circle given. So now this is very, very important problem, most expected question in the examination. Please try to concentrate all of you this question. This is very, very important. Right. So first let us write now here. Given equation, write down. Given equation. Given equation. Given equation is x minus a whole square plus y minus b whole square is equal to r square. Say equation 1. So just think for a while, what shall we do? What shall we do? Okay. Differentiating both sides with respect to x. Okay. So in order to differentiate, we should know the actually x to the power of n formula, power rule. D by dx of x to the power of n, already we had a discussion, that is n into x to the power of n minus 1. So x minus a whole square differentiation becomes 2 times x minus a. Again x minus a differentiation is, actually a is a constant, arbitrary constant, 0, x differentiation 1. So 2 into x minus a. In the similar manner, y minus b whole square is very, very important while writing. 2 times y minus b, but y minus b differentiation is, y derivative is y1, b derivative 0. So y1 it should be written. Here already clear mentioned, it is mentioned that r is constant, r square differentiation is 0. So from this we can find out actually here, now divide both sides by 2. Divide both sides by 2. So having been divided both sides by 2, what do we get now here? X minus a plus y minus b times y1 equal to 0. Say this is equation 2. Okay. So now again differentiate both sides with respect to x now, because here we have the two arbitrary constants. Again differentiating both sides with respect to x. Then what do we get? X minus a differentiation, x differentiation 1, a differentiation 0, 1 plus this y minus b into y1. So you need to differentiate this one using product rule, UV formula. So y minus b into derivative of y1 is y2 plus y1 into y minus b derivative is y1, because b derivative is 0. So here 0. Then what do we get here now? Actually 1 plus y minus b times y2 plus y1 into y1 is y1 square equals to 0. So let us transpose 1 plus y1 square to the right hand side. Otherwise say equation 3. Now again we get here. So it can be rewritten as y minus b times y2 equals to minus 1 minus y1 square. You can have minus of 1 plus y1 square. So let us think, can you find out y minus b value from this one? Yes, why not, we can find out. Here see how do you find, here. See now y minus b equals to negative of 1 plus y1 square upon y2, right. So now if you substitute y minus b value in equation 2, you get x minus a value. After getting x minus a, both x minus a and y minus b simultaneously we need to substitute in equation 1 so that a and b both parameters can be actually here eliminated. So let us proceed. So now substituting y minus b equals to negative of 1 plus y1 square upon y2 in equation 2. So in the place of actually y minus b, let us substitute this one. See what do we get now here. It's very interesting here. What will happen means I will tell you, don't worry. So now if you substitute y minus b here, we get x minus a plus, in the place of y minus b you can write negative of 1 plus y1 square upon y2 multiplied with y1 equals to 0. Right. Now this can be rewritten as x minus a, so this is plus into minus, you get minus of y1 into 1 plus y1 square upon y2 equals to 0. So that we can find out the value of x minus a in terms of y1 and y2. So x minus a is equal to, we have transposing this side, we get y1 times 1 plus y1 square upon y2. That means we know y minus b and we know x minus a. Both are to be substituted in equation 1. So what is the equation 1? Let us see. So this is the equation 1. X minus a whole square plus y minus b whole square is equal to r square. So let us substitute the values, both the values, x minus a and y minus b. So now write down from equation 1. What is the equation? That is x minus a whole square plus y minus b whole square is equal to r square. In the place of x minus a, substitute this one, but x minus a whole square. So therefore we get x minus a whole square means y1 square, next 1 plus y1 square whole square by this y2 square plus y minus b whole square. Y minus b is minus 1 plus y1 square by y2, that we can write 1 plus y1 square whole square upon y2 square equal to r square. So multiply both sides with y2 square or take LCM y2 square and cross multiply. So multiply both sides with y2 square. Then what do you get? y2 square into first term, y2 square gets cancelled. y2 square into second term, y2 square gets cancelled. We have here r2 square into r square into y2 square you will be getting. So y1 square into 1 plus y1 square whole square plus 1 plus y1 square whole square is equal to r square multiplied with y2 square. So just observe the left hand side. What do you observe? Actually here we have 1 plus y1 square whole square, 1 plus y1 square whole square is the common term. So that we can take out common term. Take out common term now. So having been actually taken common out 1 plus y1 square whole square, what do we get now? 1 plus y1 square whole square into, you will be getting 1 plus y1 square equal to r square y2 square. See, if you multiply these two, 1 plus y1 square whole square into 1 plus y1 square, you get 1 plus y1 square whole cube equal to r square into y2 square. So therefore here we get, in the place of y1, dy by dx, write down dy by dx whole square and raised to 3 whole cube equal to r square into y2 means you can write second order derivative d2y by dx square whole square. So this is the required differential equation. This is the required differential equation. This is very important problem. So my dear students, please do this problem by your own. You practice at least for 2 or 3 times. This is very important and very easy also. So I will show the total method once again, problem also. So this is the problem, right? 16th problem. First, all of you go through the question first of all. Right? Okay. See, form the differential equation of the family of the circles x minus a whole square plus y minus b whole square is equal to r square, where a comma b are parameters and r is constant. So given equation is x minus a whole square plus y minus b whole square is equal to r square. Say equation 1. Differentiating both sides with respect to x. X minus a whole square differentiation is 2 times x minus a plus y minus b whole square differentiation is 2 into y minus b multiplied with derivative of y minus b is y1 because b derivative is 0 is equal to r square is constant, r square differentiation is 0. So divide both sides by 2, we get x minus a plus y minus b y1 is equal to 0. Say equation 2. As it contains 2 arbitrary constants, again we need to differentiate with respect to x. So again differentiating both sides with respect to x. So x minus a differentiation 1 plus, this is UV method, y minus b into y1 derivative y2 plus y1 into y minus b derivative is y1 equal to, again 0 derivative with respect to x, 0 only. 1 plus y minus b y2, y1 into y1, y1 square is equal to 0. From this, actually here, from this, so here, from this, we get actually y minus b into y2 equals to, take 1 and 1 plus y1 square to the right hand side, we get minus of 1 plus y1 square. Am I right? Now we can find out y minus b equals to minus of 1 plus y1 square by y2, right? Substituting y minus b is equal to minus of 1 plus y1 square by y2 in equation 2. So in this equation, so then what do we get? X minus a plus minus of 1 plus y1 square by y2 into y1 is equal to 0. So this we can write x minus a plus into minus minus y1 times 1 plus y1 square by y2 is equal to 0. So from this we can find out the value of x minus a. X minus a is equal to, so if you transpose minus y1 into 1 plus y1 square by y2 to the right hand side, so we get that is x minus a is equal to y1 into 1 plus y1 square by y2. Right. So now as we know y minus b value and x minus a, let us substitute in equation 1. We have equation 1 is x minus a whole square plus y minus b whole square is equal to r square. Substitute x minus a value this one and y minus b value is this one. So x minus a whole square, y1 into 1 plus y1 square by y2 whole square means y1 square 1 plus y1 square whole square by y2 square plus actually here y minus b value. What is y minus b value? So y minus b is minus of 1 plus y1 square by y2. So by squaring y minus b, what do you get? 1 plus y1 square whole square by y2 square, that is equal to r square. Multiply both sides with y2 square. So this y2 square will be eliminated and r square into y2 square you will be getting. So now 1 plus y1 square whole square, 1 plus y1 square whole square taken common out. So if you take common out, 1 plus y1 square whole square into 1 plus y1 square is equal to r square y2 square. So 1 plus y1 square whole square into 1 plus y1 square means 1 plus y1 square whole cube is equal to r square y2 square. Okay. Right. So next, actually in the place of y1 write dy by dx, in the place of y2 d2y by dx square. So 1 plus dy by dx whole square whole cube is equal to r square into d2y by dx square whole square. This is the required differential equation. I hope it's very clear to you. So Pragnya Pininti, Vikas Dundigala, welcome Vikas, Pragnya. Okay, right, I have noted, but this class is also very important. Once again you attend, for this will be useful for the concept wise, so that classes will be started shortly. Okay, thank you. So stay tuned for the classes, right. Next let us move to, we have completed this question now. 17th question. Let us move to the 17th question. 17th question. 17th question. Form the differential equation. Form the differential equation. Form the differential equation. Form the differential equation by eliminating arbitrary constant. So that is given actually here, see, arbitrary constant tan x tan y equals to c. Tan x tan y is equal to c. Actually here c is the parameter. Or we can say that arbitrary constant. So now only one arbitrary constant is present. So differentiate both sides with respect to x, so that we get the differential equation directly itself only. So given equation is so what is the given equation? Given equation is tan x into tan y equals to c, which is arbitrary constant. Differentiating both sides with respect to x. Now left hand side is in the form of product of two functions, tan x into tan y. That means UV rule you need to be applied. So now let us apply UV rule now here. So derivative of tan x into tan y means we have tan x into d by dx of tan y, derivative of x with derivative of tan y with respect to x, plus tan y into derivative of tan x, d by dx of tan x, derivative of tan x with respect to x, equal to d by dx of constant, arbitrary constant. Right. So this is a standard result, d by dx of tan x. See, d by dx of tan x, derivative of tan x is secant square x, secant square x. So obviously the derivative of tan y is what? So d by dx of tan y, derivative of tan y is also secant square y, but it's very important, it should be get multiplied with the derivative of y, that is nothing but dy by dx or y1. So this you must remember. So now what do we get now here? Tan x into derivative of tan y is secant square y, but y differentiation with respect to x, that is dy by dx, plus tan y into derivative of tan x is secant square x, equal to 0. So this is the required differential equation, right? So this is the required differential equation. Therefore this is the required differential equation. So in order to solve this problem, better you remember these two formulae. These two are standard results. Derivative of tan x with respect to x is secant square x, derivative of tan y with respect to x is secant square y, and dy by dx. I hope it's very clear to you. Okay, let us proceed to next question now. Next question. So 18th question. Form a differential equation, form a differential equation by eliminating arbitrary constants, arbitrary constant. So that means from the given equation, that is nothing but secant x plus secant y equal to c, where c is the parameter. In brackets I mentioned, again is the given equation, that is c is the parameter, or we can say that arbitrary constant. So just note down the question, try to solve it, and you can chart with me your answer. You can share your answer. I will give 2 minutes time to you. Try to solve this question. Okay. So now all of you check your answers. What is the given equation here? Yes, this is the given equation. Secant x plus secant y is equal to c. So given equation is secant x plus secant y is equal to c. Say equation 1. So as we have only one arbitrary constant, it has to be differentiated for one time itself only. But before going to differentiate, we should know the derivative of secant x. D by dx of secant x is equal to secant x tan x. So now easily now you can write what is the derivative of secant y. Derivative of secant y with respect to x. Secant y and tan y So dy by dx multiplied with dy by dx. It's very important. So with the help of these two results, easily we can solve. Differentiating both sides. Differentiating both sides. Differentiating both sides with respect to x. So derivative of the left hand side is u plus v rule, du by dx plus dv by dx only. So the first derivative of secant x is secant x tan x, clear, plus derivative of secant y is this one, secant y tan y. But here very important, dy by dx is equal to derivative of constant is 0. So therefore this is the required differential equation. I hope it's very clear to you. Right, I will give one more question, try to figure it out. This question. 19th question. 19th question. Form the differential equation. Form the differential equation. Form the differential equation. Form the differential equation by eliminating arbitrary constants. Arbitrary constants. Arbitrary constants. That means given equation is here, xy is equal to a into e power x plus b into e power minus x. Here both a comma b are parameters. Both a comma b are parameters. Try this question. Try this question. Vikas, are you there? Pragna, Pininti, are you there? Yes. Right. Form the differential equation by eliminating. This is also very important problem. Very important problem. Very important problem. Okay. So in order to solve this question, we should know the derivative of e power x, derivative of e power minus x and uv rule. So with the help of these two, easily this problem can be cracked, solved. So now the solution, given equation is xy, x into y, xy is equal to a e power x plus b e power minus x. Say equation 1. So differentiating both sides with respect to x. So now you remember these two formulae. uv old dash is equal to u first function into derivative of second function plus second function and derivative of first function. This is one formula you need to remember. Okay. Next, d by dx of e power x. It's very beautiful function. E power x derivative is e power x. Integral of e power x also e power x only. This is the one and only one function whose derivative and whose integration is same. So d by dx of e power x is e power x. Next, d by dx of e power minus x. It's very interesting. E power minus x and minus x differentiation is minus 1. So minus e power minus x. So let us try to solve it now. So this implies we get xy is UV method. X into derivative of y is y1 plus y into x derivative 1 equal to a into derivative of e power x with respect to x is e power x and plus b into e power minus x derivative. B into e power minus x derivative is minus e power minus x. So now this we can write x y1 plus y is equal to a e power x minus b e power minus x. Am I correct? Plus b into minus b e power minus x. Say equation 2. Again we need to differentiate. Again differentiating both sides. Differentiating both sides with respect to x. Now xy1 derivative, UV rule itself only, x into y1 derivative is y2 plus y1 into x differentiation 1 plus y derivative is with respect to x is y1 a into e power x derivative. What is the e power x derivative? E power x minus b into e power minus x differentiation, that is minus e power minus x. Let us simplify. What do we get now here? X y2 plus y1 into 1 y1 plus y1 equal to a e power x minus into minus plus b e power minus x. Again actually it's very interesting. If you observe this one, a e power x plus b e power minus x is nothing but from equation 1 xy. So from equation 1, this say equation 3, from 1 and 3 we can write a e power x plus b e power minus x is being replaced by xy. So now say this is equation 3. So let us do it now. So now we can write from equations, sorry, 1 minute. Still we need to simplify. So this can be simplified, x y2 plus 2y1 equal to a e power x plus b e power minus x. This is equation 3. Now let us write. Okay, from equations 1 and 3. So here actually a e power x plus b e power minus x is xy. So we can have now, that implies we get xy2 plus 2y1 equal to y. Take y this side now. So xy2 plus 2y1 minus y equals to 0. So this can be rewritten as x into d2y by dx square plus 2 dy by dx minus y equals to 0. So this is the required differential equation. This is the required differential equation. Therefore, this is the required differential equation. Clear? I hope you might have followed. So once again you can check, or if you want you can take the screenshot also. So that is our wish. So you need to chat through live chat so that I can interact with you. So I put once again subscribers mode itself only. You need to subscribe to chat with me. Right. See this question once again. So this is the given equation, xy is equal to a e power x plus b e power minus x, differentiating both sides with respect to x, d by dx of xy UV method. So x into y derivative is y1 plus y into x derivative 1 equal to a into e power x derivative is e power x plus b into e power minus x differentiation is minus e power minus x. Here xy1 plus y equals to a e power x minus b e power minus x, say equation 2. Again differentiating both sides with respect to x. Here now see xy1 differentiation is x into y1 derivative y2 plus y1 into x derivative 1 plus y derivative is y1 is equal to a into derivative of e power x is e power x minus b into derivative of e power minus x is minus e power minus x. Let us substitute here. So now xy2 plus y1 into 1 y1 plus y1 equals to a e power x minus into minus plus b e power minus x. So now xy2 y1 plus y1 2y1 equals to a e power x plus b e power minus x, say equation 3. If you observe equation 1, a e power x plus b e power minus x nothing but y. So now this is replaced by, actually sorry, this is xy we can replace here, not y. So sorry, absolutely. A e power x plus b e power minus x is xy we can replace. So xy, wait, okay, once again you can write all these steps now. So let me write once again. Now actually from equation 1 and 3 what do we write? xy2 plus 2y1 equal to xy we can write. Bring xy this side, xy2 plus 2y1 minus xy is equal to 0. So therefore we can write now this also, x d2y by dx square plus 2 dy by dx minus xy is equal to 0. So this is the required differential equation. This is the required differential equation. So this is our answer. Clear? Okay. Okay, so now right, this is the question number 19. Let us move to question number 20. Right, question number 20. Question number 20. Form the differential equation. Form the differential equation. Form the differential equation form the differential equation by eliminating the arbitrary constant from secant y plus secant x is equal to c plus x square by 2. Here c is the parameter. C is the parameter. Okay, let us try to solve this question now. So let us try to solve this question. Let us try to solve this question. Right. How many arbitrary constants are present in the given equation? Only one. So differentiate one time so that you will get the answer. Right. Let us proceed for the solution. Solution. Given equation. So given equation is secant y plus secant x c plus x square by 2. Say equation 1 this is. So just we had a discussion about the derivative of secant x also, d by dx of secant x. So for the benefit of late viewers, once again I repeat the formula. Formula are very important, standard results. D by dx of secant x is secant x and tan x. So whereas d by dx of secant y. So secant y differentiation is secant y tan y is very important, multiplied with the derivative of y with respect to x, that is dy by dx. So you must remember these two results. So with the help of these two results, easily we can find out the differential equation here. Differentiating both sides. Differentiating both sides with respect to x. So then what do we get? Derivative of secant y is nothing but secant y tan y y1, or you can write dy by dx, plus derivative of secant x is secant x tan x, plus c differentiation is 0, plus 1 by 2 into derivative of x square is 2x. 1 by 2 into 1 by 2 is constant, derivative of x square is 2x. So then we can have secant y tan y dy by dx plus secant x tan x equals to 0 plus something 2 gets cancelled, we have x. So this is the required differential equation. This is the required differential equation. Right. So we have completed 20 problems. Enough. Tomorrow I shall give some practice problems to you. So that practice problems will be solved later after 1 week. But till then actually we shall start how to solve the differential equations of first order and first degree equation. So first we shall discuss about the concept of that one. After that we shall solve the problems in different methods. So till then, goodbye. Thank you. Bye bye. Have a nice day.